Find the slope of the line that passes through the given points. We use the formula y2 minus y1 divided by x2 minus x1. So we have -5 minus -9 and -1 minus 2. Here, when we have subtracting a negative, we change it to addition. -4 plus, or -5 plus 9 is 4, and -1 minus 2 is -3. So this is a slope of -4/3. Does this table represent the situation? Well, we know that the entrance fee costs $10, so even if she buys 0 tickets, she still has to pay $10 to enter. Then each additional ticket that she buys is $2.50 more. So if we add $2.50 to that $10, we end up with $12.50 for one ticket with the entrance price. And it increases by $2.50 when we increase the tickets by 1. So yes, this does represent the situation. It is also a function because the inputs each have exactly one output. We wouldn't be able to buy 3 tickets at a different price. Anytime we buy 3 tickets, we have to pay the $10 entry fee and then the extra $77.50 for that set of 3 tickets. Here is the graph of those values. You can see the number of tickets purchased on the x-axis and the total amount of money spent in dollars on the y-axis. These points all appear to make a straight line. So these are a linear function since they fall in a line. Linear functions, we can use the template y equals mx plus b like we did in previous modules. You can see that it starts on the y-axis at 10, and it increased $2.50 for each ticket. So we can write the equation y equals 2.5x plus 10 to represent the equation of this line. Now, since it is a function and it forms a straight line, we call this a linear function. Jonas's bathtub is empty. The plug is in the bathtub, so any water added will not drain out of it. Water begins to flow from the faucet into the bathtub at a constant rate of 7 gallons of water every 2 minutes. Describe the inputs and outputs for this situation. Then complete the table to represent the relationship by filling in inputs and their corresponding outputs. In this specific situation, the inputs would be the the minutes, and the outputs would be the gallons of water. So in 0 minutes, since it was empty, there would be 0 gallons of water. In 1 minute, it says 7 gallons every 2 minutes. So in 1 minute, we would expect there to be 3.5 gallons. Can this situation be represented by a function? Explain your thinking. Yes, the gallons change as a function of time. At each time, there is a specific amount of gallons. We can't say at 1 minute there was 3.5 gallons, but also a different amount of gallons in the tub. So then it says write an equation. We know that it started at 0, 0, so our b value must be 0. And our slope was 7 every 2 minutes. Or you can think of that as 3.5 every minute per minute. Can this situation be represented by a linear function? Yes, it has a constant rate. How many gallons of water are in the bathtub after 5 minutes? Well, let's plug in 5 into the value of x. 3.5 times 5 will tell us how many gallons are in there after 5 minutes. And that is 17.5 gallons. If the bathtub can hold 51 gallons of water, how long does it take to fill the bathtub? The gallons was the y value. So to solve that, we would divide both sides by 3.5. So 51 divided by 3.5 will tell us how many minutes it's going to take. That is 14.57 approximately. Or we can say about 14.6 minutes. Yu-Yon's 50-gallon bathtub has 8 gallons of water in it. The plug is in the bathtub, so any water in it or added to it will not drain out. So that means at time 0, there's already 8 gallons in there. Water begins flowing out of the faucet at a rate of 7 gallons of water every 2 minutes. Describe the inputs and outputs of this situation, then complete the table. The inputs, again, is time in minutes. And the outputs is the gallons of water. In 2 minutes, we got an extra 7 gallons. So 8 plus 7 is 15. In 1 minute, we would have got an extra 3.5 gallons. So 8 plus 3.5 is 11.5 gallons. In this situation, we represented by a function. Yes, each time interval has exactly one output. Write an equation for this situation. The rate was the same, but this time instead of starting empty, it started with 8 gallons. Can this be described by a linear function? Yes, it has a constant rate. And it had an initial value, also known as a y-intercept. How long does it take to fill Yu-Yon's bathtub when it starts with 8 gallons of water in it? Back at the beginning of problem 2, it tells us that Yu-Yon's bathtub can hold 50 gallons. So that's the x value, the y value, and we need to solve it for the x value. We'll subtract 8 from both sides. That leaves us with 48 equals 3.5x. Then divide both sides by 3.5. So x is approximately 13.7 minutes. I did not subtract that correctly. That should be 42, not 48. Let's try that again. 42 divided by 3.5 is 12 minutes. What input makes sense in this context? So any inputs from 0 through 12 would make sense in this problem. We wouldn't want negative time, and we don't want to overfill the bathtub. Liam can buy walnuts for $8.50 per container. Complete the table by entering the values of x and y to represent the situation. Well, if he buys 0 containers, he should pay $0. If he buys 1 container, he would be paying $8.50, and 2 containers would be $17. Can this situation be represented by a function? Explain your thinking. Yes, each number of containers is assigned exactly 1 set price. Write an equation to represent this situation. There's no initial value. If you buy 0 containers, you would pay $0. Can this be represented by a linear function? Yes. The price is a constant rate. What inputs make sense in this context? Well, we wouldn't want negative amounts of containers, and we don't want fractional amounts of containers. You buy the whole container at the store. So it should be whole numbers. So 0 or larger. No negative numbers. And we want them to be whole numbers. What is the price of 12 containers of walnuts? Well, $8.50 times 12 is 102, so $102. A pet shelter has 450 cans of pet food that were donated through a school's canned pet food drive. A local business pledges to donate an additional 15 cans of pet food a week to the shelter. Complete the table by entering values of x and y to represent the situation. So on week 0, they have already donated 450 cans. And they agree to donate 15 cans per week. So 1 week later, 15 more cans have been dropped off, which would put them at 465. And then another week later, an additional 15 cans will be donated, which would be 480. Can this be represented by a function? Yes. It has an initial value. Oh, that's going to be the linear part. Yes, it assigns one amount of cans to each week. Write an equation that represents this situation. The rate of cans being donated is 15 per week, but they started with 450 already donated. Can it be represented by a linear function? Yes, it has an initial value. And a constant rate. What inputs make sense in this context? Since they make their donations once per week, we would want whole numbers for the weeks. And again, it needs to be a positive value. No negatives will work. How many weeks does it take to have 705 cans donated? The Y values represents the cans, and the X values represent the weeks. So to solve it for the weeks, we're going to subtract 450 from both sides. 705 minus 450 is 255. Then we'll need to divide by 15 on both sides. And we get 17 for X, which means it will take them 17 weeks. That's the end of lesson 3 for module 6. Check back for more videos on the YouTube channel or in this specific playlist.